everyone, Ismail is here. Today we're going to learn about 2.2 polynomial function. This lesson is easy lesson, okay, but you need just to focus on some parts and some examples. Now, what we're going to learn how we can graph the polynomial function, okay, and we are going to learn about how we can model some real world, but now let's focus on the graphing polynomial. As you can see here, we have some vocabulary: polynomial function, leading coefficient, leading term, turning point, and repeated zero multiplicity. This is what we are going to focus on because these are the very important part. Now, before we start here, let's go through some polynomials, okay, or let's say you are familiar with some polynomial like a constant functions. So a constant function example, when you have y equal 5, y equal 6, y equal 7, or whatever, okay. So all of these considered as a polynomial function, as a constant function, sorry. Then we have the linear function. You know that the linear function formula is mx plus b, right? Mx plus b. So if you need to graph any linear function, you start graphing from b, which is y-intercept. Then you take the rise over run from the graph, okay. Then we have the quadratic function. The quadratic function, you already know it, which is x squared, or let's say is ax squared plus bx plus c equal 0. So this is the quadratic function. Now, what is about the polynomial? The polynomial, here are some examples about polynomial. Now, this example about polynomial function has defined and continuous for all real numbers and have smooth rounded terms. As you can see, this is round, this is round, this is round, this is round. This is what we call polynomial. What is not polynomial function? We don't consider them as polynomial when I have a function that has discontinuous. So as you can see, there is jump discontinuity here, so this one is not a function. And as you can see here, sharp corners, it's similar as the absolute value function here. Also, this one not considered as a polynomial, okay. I hope you understand this. Now, before we go through this example here, let me just remind you with some parts of the polynomial function. You know that when we studied this, when I have x to the power of 2, x to the power of 4, or x to the power of 6, when n is even, okay, sorry, when n is even, when the power n is even, so always the graph will be like a parabola. I think you remember this one, okay. And when the function is x to the power of 3, x to the power of 5, x to the power of 7, x to the power whatever, and n is odd function, odd power, odd degree, the function it's like starts down, okay, ends up. So always the function is like this. And if the function is negative, okay, if a is negative, so the function will be it will be reflected over x-axis, and here it will be reflected over the origin. This is what you can see here, okay, when I have a negative sign. Now, this is the even and the odd. Now, in this in this lesson, you know that how we can graph this one. If I have h and k, because h and k is mixing, okay, or it's showing me the translation. We know that h is translated right or left, right, okay, right or left, maybe right, or we are translating on the right and on the left, and always we take the opposite sign of h. So if I say that I'm going -3, so I mean 3 steps to the right. If I said example 4, so that's mean left, so I'm going 4 to the left side, okay. Now, say k is different. K is the translation, you know that it's up and down, okay, up or down, the translating, and k it's always same sign. If saying +5, so 5 step up, -7, so let's say negative 7 steps to the down, okay. And don't forget that if the x with any number like this one square, so that's mean this 5 here represent h or k. This one of course is h. If the function x squared plus example or -3, so now this 3 here represent as k. Why this is k, this is h? Because as you can see, x with h always related, but as you can see, this x is alone and this 3 is alone, so that's why we consider this one as a k. Now let's go this example here. Graph transformation of motional function. Now as you can see, we have the function here, f of x is equal x minus 2 to the power of 5, okay. We know that to the power of 5, this is odd, right? and because it's on it, the function, it will be starts down, ends up. It's like this. Okay, and h and k here, if I need to know h and k, h is given, which is equal -2. So we take the opposite sign of -2, we take it 2. And do I have k? K, it should be minus or plus anything here, but I don't have anything here. So k, it's equal 0. Now if I need to graph this one, it's 2 steps to the right from the origin. 1, 2 steps to the right, then you can graph my function. Okay, now how about this one here? So as you can see, okay, to graph this function, we look to the power. The power is even, and because it's even, it's like a parabola. Now what is h and k here? H and k. H, I don't have h because the number positive one is outside the x, is outside the power, so 1 is k. Now if I need to graph the function, it should be parabola, but now look to the a. A is positive or negative. Okay, as you can see, a, the leading coefficient, is negative, so that's means the parabola will be reflected over the x-axis. The graph will be like this one here. But if you look here, a is positive 1, so when I need to start, it will have to be 0, 1. Okay, and it will go down, so the graph will be like this one. Okay, now I have here a question for you. Try to solve this question, and if you need help, please ask me. Okay, now apply the leading term test. Okay, same thing here. Now we learned, as I explained to you, that if I have, okay, if the polynomial is only x to the power of 2, x to the power of 4, and only one term, as you can see, it's only, okay, only one term. You know that the polynomial can be binomial, trinomial, 4th degree, 5th degree. Okay, so as you can see, this one is only one term, which is, we call this one monomial, right? So when the function is a monomial, okay, or let's say a variable with a number, so the graph always, the shape of the graph will be like this. Okay, the graph, if it's even, it will be like this, or if it's odd, it will be like this. Now in the polynomial function, if I have many terms, okay, if I have, example now, if I have x to the power of 2 plus 2x, okay, minus example 1, or if I have x to the power of 4 plus 3x squared minus 2x and plus 3, or if I have x to the power of 6 plus x to the power of 4 minus 3x cubed plus 2x squared minus 1x. Okay, so as you can see now, all of these considered a polynomial when the polynomial has more than one term. So this is one term, this is one term, this is one term. So as you can see, if the polynomial has more than one term, the graph, okay, it will not be only a parabola. The graph will have many, okay, many shapes. Means, okay, here, if first, well, these, look to the power. Now the power here is even, the power here is even, the power here is even. So when the graph will be like this. Okay, this is for the first one. Okay, for the first one, it will be like this. It will start, you have to remember it like this. Starts, the graph always we start from left to right. So when I said starts up, so that's mean I'm saying from the left it starts up, and ends, okay, end up. Okay, start up, end up, means from the left it start up, then on the right it ends up, as you can see. Now also for the when x to the power of 4, so you have to do 4 means how many x intercept. Here in the first graph I have 2x intercept. Okay, this is the first, this is the second. Now when I'm talking about x to the power of 4, of course I will have 4x intercept. Just example, 1, 2, 3, 4. So now when I need to start graphing, I start up, okay, goes down, go through with every point, then I go ends up. So starts up, ends up. Now if I'm talking about x to the power of 6, so of course I should have 6 intercept, 3, 4, 5, 6. So I have to start up, go through the first point, then I have to turn between 2 points, then I have to turn between 2 points, go through every point, then as you can see here also starts up, ends up. So all of these, when the x is en, the power is even, okay, when the power is even, I starts up, ends up. Okay, now when I'm talking about x to the power of 3 plus 2x squared minus 1, or x to the power of 5 plus x to the power of 4 plus 3x to the power of 3 minus 2x squared, or let's say x to the power of 7 minus x to the power of 5 plus 7x squared plus 10x. Okay, so as you can see, look to the power here. The power here is odd. 3 and 7, 4, 5 and 7. Okay, all of these, the power is odd. We know that the graph of the odd function, it's like this. So it will not be any more like this if I have more than one term. So this is one term, this is second term, this is the third term. If I have more than one term, the graph, it will not be similar to this. But it will take the end behavior, which means it will start down, ends up. So the graph of the, when it's an odd, the graph, it will, let's write it here, start, okay, start down, okay, end up, okay. So as you can see, the graph will start down and end up. So if I need to graph now every one of these function, let me erase this, okay. Now if I need to graph every one of these function, now how many x-intercept do I have here? Look to the power, I have 3, so of course I will have 1, 2 and 3. Now when I need to graph, I start down. So start down from the left, go through the first point, turning point, the second point, then turning point, go to the, so as you can see, starts down, ends up. Same thing now if I need to do the x to the power of 5. So how many x-intercept? 1, 2, 3, 4, 5. So it starts down from the first one, go through the second one, the third one, the fourth one, then the fifth one, so it ends up. Same thing here. So what do you think it will be for x to the power of 7? Same thing. I should have 7 x-intercept on the graph, and the graph will start down, go through every point here, then it will end up. So this is when the power is even, okay. When n is odd function, okay, the graph will be starts down, ends up. You have to memorize it like this, so when you start to graph it, the function, it will be easy to you. Now how about if the leading coefficient is negative? So if I have a negative here, negative here, negative here, negative here, same thing if I have negative here, or here negative, or here, the leading coefficient is negative. What's happened to the graph? The graph never changed, but only will reflect it over the x-axis. So if this one is upward, so it will be downward. If this graph starts up, ends up, no, it will start down and ends down. Same thing here, it will start down and then it will end down. So this is when a is negative. Same thing happen here. So it's a start down, ends up. So when a is negative, it will start up, okay, and it will end down. So it starts up and go through every point, then ends down. So this is what you can see here, starts up, ends down, okay. So this is when apply the leading coefficient. Okay, now let's start solve this example. Applying the leading term test. So applying the leading term test, as you can see here, describe the end behavior of the polynomial function. So we need to mention the end behavior of the polynomial function. We know that if n is even, okay, starts up, ends up, okay, and when the power n is odd, okay, it's start, okay, down, sorry, I wrote down here, sorry, again, let me repeat this. So when n is even, it starts up, okay, and ends up. When n is odd, okay, it starts down, ends up, okay. This is when a is positive. When a is negative, it will, when a is negative, okay, so this one, it will be down, down, starts down, ends down, and this one, it will be the opposite, starts up, ends down. Don't forget this, okay. Now what I mean about starts down, ends up, up means it will be positive infinity. Up here it will be positive infinity. When I mean down, so I mean negative infinity, I mean negative infinity. Same thing here, when I said up, down, it will be negative infinity, and when I say up, it's positive. Same thing here, positive, and here same thing, it's negative. Now look to this one here. When the function, okay, now I need to see this side here of the x, okay, when x approach positive infinity, and this side here on x means x approach negative infinity, okay. Now when x approach positive infinity, the graph goes where? up, so that's mean it's positive infinity. When x negative infinity, so the graph also up, it's positive infinity. So this is what you can see when I said look to the power. What's the power? It's even, so even, of course, it's up and up. Okay, and a, don't forget, look to the a. If a is positive and the power is even, so it's up. So the limit for both sides, it will be positive infinity, positive infinity. Okay, now look to this graph here. So look to the power first. The power here is even. Okay, even means starts up, ends up. But look to the leading coefficient. The leading coefficient a is negative, so it will starts down and also it will end down. So when I need to write now the end behavior, I can write limit when x approach positive, f of x is equal negative infinity. Why? Because it's down. And when limit f of x when x approach negative infinity, f of x also it will be negative infinity because also it ends down. Okay, now let's do this. Look to the power. What's the power? It's odd number. Odd number means starts down, ends up. Now look to the leading coefficient. Is it positive or negative? It's positive. So because it's positive, so it will start down, ends up. So limit when x approach negative infinity, always start with a negative. So a limit when x approach negative infinity, as we know, this is down, starts down and ends up. Because it starts down, so it will be negative infinity. Okay, and limit f of x when x approach positive infinity, so f of x is equal positive infinity. Why? Because it's up. Okay, I hope you understand this. Now try to solve this question. I give you here some exercise. Try to solve them. If you need help, please ask me.